ట్రాన్స్ఫర్ ఫంక్షన్ అంటే అవుట్పుట్ బై ఇన్పుట్ అని అనుకున్నాం కదా. సో దీన్ని ఎనీవే ఇట్ ఇస్ ఇన్ టర్మ్స్ ఆఫ్ లాప్లాస్ ట్రాన్స్ఫార్మ్ కాబట్టి ఒక పర్టికులర్ మెథడ్లో రాస్తే ట్రాన్స్ఫర్ ఫంక్షన్ క్యాన్ బి రిటర్న్ లైక్ దిస్: k into s minus sa into s minus sb and so on till s minus sm by s minus s1 into s minus s2 so on till s minus sn. So ikkada ee numerator and denominator have different functions in a transfer function. First konni transfer function lo unna konni terms telusukundam. Poles are those points at which the transfer function becomes infinity. Ante transfer function lo we have a denominator, right? S minus s1 into s minus s2 so on till s minus sn. E denominator, if it becomes 0, then obviously the transfer function becomes infinity. If 0 avvali ante any one of these parameters should be equal, like s1 should be equal to s or s2 should be equal to s. So for this to be possible, oka example తీసుకుంటే we have a transfer function 2 into s plus 2 by s plus 4 whole square into s square plus 2s plus 2 into s plus 1. So ikkada denominator is this part. E part 0 avute transfer function can be infinity, and a points lo aithe this denominator becomes 0, those are called as poles. If we consider this denominator, ఇది 0 avvali ante s should be either equal to minus 1 according to this part, or s should be equal to minus 4 according to this part, or else ఈ equation ni manam solve cheste whatever value we get. For example, s square plus 2s plus 2 ni 0 anukoni solve cheste whatever values we get for s, x and y, e values will be poles anamata. So finally poles are those points at which the transfer function becomes infinity. Next we have zeros. Name depicts zeros are those points where the transfer function becomes 0. Ante similar example indaka chusina example chuste ikkada numerator 0 avute transfer function will be equals to 0. Numerator 0 avvali ante s should be equal to minus 2. So s equals to minus 2 is the 0 of this transfer function. S equal to minus 1, s equal to minus 4, and all these other points are called as poles of the transfer function. And the next term we have characteristic equation. Characteristic equation is related to poles. Ela ante an equation whose roots are poles. It's nothing but the denominator of the transfer function. Ante kada poles ante em anukunnam, the denominator, if the denominator 0 avute those points will be poles. Denominator 0 ayindi ante denominator lo unna equation ki those points are roots, right? If the equation becomes 0 at a particular point, that point is called as the root of that equation. So characteristic equation ante the equation for which roots are poles. So find this example lo this equation s plus 4 into s square plus 2s plus 2 into s plus 1 is called the characteristic equation of that particular system. So a system ki transfer function manam define chesamu ante we automatically get all these points, zeros, poles, and the characteristic equation of that particular system. These are the parameters which define the characters of a particular system. So oka system ki ivanni define chesin tarvata we can draw a plot called as pole 0 plot, in which this will be the real axis, idi imaginary axis avutundi, and poles are denoted by a cross and zeros are denoted by a dot or a circle. So this particular equation lo s equal to minus 1 was a pole, s equal to minus 4 was a pole, s equal to minus 2 was a 0. So ee figure lo idi s axis avutundi. If s is equals to minus 2 somewhere here, this will be denoted like this as a 0. It's equal to minus 1, దీన్ని ఒక క్రాస్ తో డినోట్ చేస్తాం. s equal to minus 4 ని ఇంకో క్రాస్ తో డినోట్ చేస్తాం. This will be the pole zero plot of a system. So once we are able to find the transfer function of a system, we can draw a pole zero plot of the system which defines the stability of a system. So based on pole zero plot, manam stability ane system enta varaku stable ane point telusukochu. A stability factor will be discussed later. That is under a different topic. So what we learned now is transfer function, poles, zeros, characteristic equation and pole zero plot. So problems which we get on this transfer function is, as I told you before, transfer function key will be given an impulse input which is given to a system. Ichinappudu we can easily find out the transfer function, because transfer function is nothing but C of S, that is output, that is impulse response of a system. So a particular system ki impulse input icharu annappudu, if we are given the transfer function, manam output anedi kanukochu, and that system can be easily designed. So let's look at an example. If unit impulse response of a system is given, unit impulse response, that is C of t is given, that is e power minus 4t. Response ante output. So e power minus 4t is given in a question. So what we need to find here is, find the transfer function. So according to the definition of transfer function, indaka manam chusindi, transfer function is nothing but Laplace transform of the impulse response. So impulse response is given as e power minus 4t. Deeniki Laplace transform cheste we directly get the transfer function. This is one of the most common problem given in exams. So to be more clear, sometimes manaki Laplace inverse istadu. Laplace inverse is given ante it is also Laplace inverse of a transfer function. Ante ee equation తీసుకుంటే దీనికి Laplace inverse of transfer function is nothing but the impulse response. So he won't directly tell you that he has given the impulse response. Adi impulse response ani manam ardham chesukovali based on this criteria. Laplace inverse of a transfer function is nothing but the impulse response of a system. So ala cheppinappudu we can easily find out the impulse input or the transfer function. So these are the basic problems given in exams.